All right, good day everyone. Today we're just going to discuss the Euclidean geometry, that is paper 2. And then before we get started, a lot of appreciation to those that they support the channel, and you also can do so by clicking the subscribe button, by clicking the like button, and by commenting down in the comment section. And you also can share the video to your friends. Do those nice things so that I can reach more people. So to help me to reach 100 subscribers for now, because I'm not asking for much. I'm just asking for those little things. So let's get started and say for question 10.1, it says here, complete the following theorem to make the statement true. So if a line divides two sides of a triangle in the same proportion, then the line is dash dash dash. And then what I can just say or remind you about is just that in grade 12, theorem 1, it says over there, if a line is drawn parallel to one side of a triangle, it then divides the other two sides proportionally. So what I can just say here is just that they left the part that is parallel. So that dash part there, we can replace it with a parallel. So let's say 10.1 and say a parallel here. Parallel. And then for a 10.2, let's look at 10.2. It says here two circles with centers P and S. As you can see, those are the centers, and then touch each other externally at C. You can see that. So SP produced the intercept circle P at B. Where is SP? Here is SP, and then it intercept a circle P at B. So as you can see that a common tangent at R and Q meets SB produced at T. So here is the common tangent, that is the TR. So now let's look at 10.22, and then at 10.22 it says that we are required to prove that a PQ is parallel to the SR. So to the line SR, here is the PQ, and then it is the line SR. So as you can see there, they look more parallel to each other, but we need to prove them that they are definitely parallel to each other. So first step, first things first, let me write a 10.21. We are required to prove that PQ is parallel to SR. So first things first, what I can just say to you is just that when we prove the lines that are parallel, we need to look at the three main angles that are found between the parallel line. Those angles are as follows. The first one is the one that shows an F shape, and then first of all, let me say the alternate angles that shows a Z shape, and then we have a corresponding angles that shows the F shape, and then we have a co-interior angles that show a C shape. So now those three, we can just look at them over here in order for us to prove that PQ is parallel to SR. So now for the angles that are here, what we can just see, we cannot see any Z shape here, but we can see an F shape. If you take a look here, the line SR and the line PQ join together, then they meet the same tangent, that is a TR, and then they form a F shape over here. So now what you can just take a look on, it's a corresponding angles, so it will help us a lot to answer this question. So now let's just say for the first angle, we know that in order for us to prove that they are the corresponding angles, we need to prove that this angle must be equal to that angle. So now what you can just do now is just that let's find out if this angle over here is definitely equals to this angle, or this angle is definitely equals to that angle. So what you can just do now, since you can see that a PQ is perpendicular to the line that is the tangent that is a TQ in the smaller triangle, and then a SR is perpendicular to the line that is a TR. So what we can just say over there is just that angle Q1, that is angle Q1 over there. Let's say angle Q1, firstly, we say angle Q1 is equals to a 90 degrees because of the tan that is perpendicular to the what? To the radius, to the radii. So that's it for angle Q1. Here is the angle Q1. It forms a what? A 90 degrees over there because of a what? A tan perpendicular to the what? To the radius, because this PQ is a radius and this TQ is a tangent. So over here is one of the same thing. SR is a radius and then a TR is a tangent, and then when they meet over there they form a 90. So it means that they are perpendicular. So now angle SRT is equals to a 90 degrees because of a what? Of a tan that is perpendicular to the radii. So now we're done proving that this angle is equals to that angle. So what comes in mind when we see these angles being equal to each other? It means that these one, they are corresponding angles. So what we can just do now is just that we can say angle that is a Q1 is equals to angle SRT, because this angle is equals to 90 and this angle is equals to 90, and then 90 is equals to 90. It means that these angles, they are equal to each other because they are both equals to a what? They are both equals to 90. So both equals to a 90 degrees. And then now what you can just do, since you know that this angle is equals to this angle, and then it means that these lines, they are parallel to each other because the corresponding angles, they are equal. That is our answer now. And then therefore, and then we say a PQ is parallel to SR because of the corresponding angles that are equals to each other. Corresponding angles are equal. That's our answer over there. And then we move on to the second question, and we say the second question says over here 10.22 10.22, it says that TP is equals to, are required to prove that a TP is equals to a TQ into BP plus SR, and then close the brackets over a QR. And then what you can just do now, let me write it first for you. And then it says we are required to prove that a TP is equals to a TQ, and then a BP plus a SR, and then over a QR. So this one, and the letters that are here, they show the sides, not the angles. So they show the sides. So what you can just do over here, let's look at the side that is a TP. TP is over here, and then a TQ. TQ is over here, and then a BP plus SR. A BP is over here, and then SR is over there, and then a QR is over here. It means that here what we are required to prove is just that the corollaries of the what? Of the proportionality theorem. So what we can just do, since this line they are parallel to each other, it means that we are allowed to do the what? The corollaries, because this line, they are parallel to each other, and then they tend to agree for the theorem that states the proportionality theorem. So we are required to prove that using the what? The corollaries of the proportionality theorem. So let's take a look, since we proved that they are parallel on the previous question. So let's take a look on the corollaries, and then we can just say now a TP over a PS, and then is equals to a TQ over a QR, and then is equals to a TS over TR. So now our reasoning over here, it should say that it's a proportionality theorem, a proportionality theorem, and then we mentioned the lines that are parallel. So those are the lines that is a PQ that is parallel to SR. And then now what you can just do is just that we can go and look at the sides that we are talking about. Then we have a BP plus a SR. What you can just do for a BP and the SR, we can just come here and then look for the ways and in which you can represent this BP plus SR as a one side, not a side with a not a line with two lines. We can just try to represent it with a one line. So a BP is over here and then a SR is over there. So it means that since we have a PS over here, look at here, we have a PS, and then now what I can just do for a PS is made by a CS, and then a PC. And then a PC over here is equals to a BP because of and a PQ, because this one, they are what? They are radians. And then a CS over here is equals to a what? SR, because those are the radians. So now we can just say over here, let's look at a PS. A PS first is made by a what? A CS plus a what? A CS plus a PC. And then it's just a straight line, this one. A straight line, you can just say so. And then now, let's look at ways in which SR is equals to a CS. And then now SR, we can just say is equals to a CS because of what? Those are the radii. Because those are the radii. And then a PC over here is equals to a what? Is equals to a BP because also it is a radii. So the radius, they are equal to each other. And then now, since this one, they are equal to this one, and then what you can just do, we can replace a CS with a what? SR, and now we end up having a what? A PS that is equals to a SR plus a what? A BP, because a BP is equals to a what? A PC. So now BP over here. And then now what you can just do over here, since we have a what? SR and then a BP, it means that this one is line what? A PS. And then let's go and find the corollaries in which it has a TP with a PS and then a TQ with a QR. So now here it is, and then it is a TP over a PS and then a TQ with a QR. So now what you can just do is a TP, take that one and write it over here, a PS, and then is equals to a what? A TQ over a QR. Then we can just say prop theorem with a PQ that is parallel to a what? To a SR. And then what you can just do now is just that we can then say a PS, a TP is equals to a TQ, and then we replace a PS with the SR and a BP, and then we say BP plus a SR and then we say what? Over a QR. And then that's it. And that's it for a 10.22. And then what we can just do now is to look for a 10.23. So now for a 10.323, it says over here, it says we are required to prove that TQP is similar to a triangle TRS. So here is a TQP and then a TRS. These are the triangles that we need to prove that they are similar. And then for similar triangles, I'll just show you the simplest way to get it correctly. So now let's just say over here, we are required to prove that by the way, it's a 10.23. So we are required to prove that triangle TQP is similar to triangle what? Triangle TRS. And then what we can just say, since we have those three letters there, those three letters, what do they mean? They mean that this one letter, it stands for the what? It stands for angle, and then this one letter stands for another angle, and this one letter stands for another angle, and then it ends up for similar triangles having three equal angles, and then they are written being angle, angle, angle. So now what we can just do, we can just come over here and say a T, and then we have a T over here. It means that this angle, these triangles, they start from T, here a TQP, and then a TRS. So that T angle must be equal to that T angle. So it means that a T angle for a triangle TQP must be equal to the T angle for a triangle TRS. And then we end up having a what? An angle that is a T being equals to the angle that is a T, because it is a common angle. So we can just say a common angle. And then now, what you can just do is to look for a Q. We come here and we see that we have a Q1 in triangle what? TQP. And then we have a R over here. It means that we come and look at this R. We're just gonna look for a relationship between these triangles. And then what comes in mind is just that we were proving that these lines, they are parallel to each other, and then we end up having a what? A Q1 that is equals to this angle because of the what? The corresponding angle. So it means that a Q1 over here, angle Q1 must be equals to angle R, that is SRT, S angle RT, because of a what? Because proven, we can just say proven above, you can just say so. So now what you can just do is just that we can come and say we have a P over here, and then we have a P angle P1 here, and then we have a S over there. We have an angle SS here. What you can just do, we can just name that angle as a third angle of a triangle. So now I said we have a P1, and then that is equal to angle S, that is RST, R angle ST, and then we can just say it's a third angle of a triangle. Third angle of a triangle, and then we ended up proving that triangle TQP, and then what you can just say is just that a triangle a TQP must be similar to a triangle a TRS, because of a what? We have an angle that is equals to each other, and then we have an angle that is equals to each other, and then we have an angle that is equal to each other, and then we have three angles that are equal to each other, then they end up having the what? We ended up having a what? A similar triangle. And then that's it for 10.23. Right, now let's look at the 10.2.4, and then it says here, prove that root ts squared minus cs squared is equals to the root of a, into brackets, that is a tp squared plus a bp squared minus a 2tp times a bp, then a cos s, and then times cs over bp. So what you can just what I can just firstly tell you over here is just that once we look at the this particular type of question, so what must comes in mind to you is just that whatever they replaced, whatever they did here to replace one side, we can reduce everything like this into one into those letters that they give, letters like this one and this one. We can also reduce this one into a letter like this one, in which we have two letters, that is a BP. You see, it means that it's a line of a triangle. In this case, these are the triangles that we're talking about. And then here, over here, whatever this is, we can reduce it into the line for it to represent one of the lines that are here, because we can't deal with something like this. There is no way that we can just go straight and give the answer in this type of a question. So what I can remind you about looking at this question, we once met something like this one, whereby they replaced a PS over here with a what? With a BP plus a SR. Here is the PS that they replaced it with a BP with a and a SR. So it tells us that whatever this is, it can be replaced with one line. Also this one. So now let's look at this one. First of all, what I can just do is to remind you about the cosine rule and the Pythagoras theorem. So what I can see here, and also you can see, is that we have a ts squared minus a cs squared. Where is the ts squared? Ts is here, and then a cs is here, and it cs, we know that is equals to the to SR, because this one they are the radius, so we can replace CS with a SR, and then we have a triangle that is a TRS, and then we have a side that is TS squared, and then a SR squared. It means that whatever that they did over here, they were trying to find a TR squared, and then they found a TR that is equals to a root of a TS squared. Anyway, let me write it down for you. So now what you can just do over here is to try to interpret everything that is happening over here. So now, first of all, whatever that they did in this question, so let me say over here. So now we have a, let's firstly go straight to the corollaries first of all, or maybe let's try to find whatever that is happening over here, and then we'll look at the corollaries of the similar triangles that we did prove in the previous question. So now here what you can, we have in 10.2.4, we have a what here? We have a root a ts squared minus a cs squared, and then is equals to a root of a tp squared plus a bp squared and minus a 2tp times a bp, and then times a cos angle s over here, and then we close this, cover with a square root, and then we close these brackets, and then we say a cs over a what? Over a bp here. And then now what we can just do is to try to reduce this one. Let's firstly look at a root that is a ts squared, minus a cs squared. And then let's try to look at it and say, if we are looking at the triangle that is TRS, what we have over here is TS squared. We can see that here is a TS squared. Mind you, remember that we did prove that angle Q1 is equals to angle R. They are both equals to 90 because of a tan that is perpendicular to the radius in both of these angles. And then now we can use a Pythagoras theorem because it allows us, because it has that 90 degrees over there in that corner. So now what you can just do is that since this one is a hypotenuse, a TS is a hypotenuse. So what you can just do is that we can say over here now, a TS squared is equals to, here is the TS squared, it's a hypotenuse. We can add SR and the TR, SR squared with the TR squared to get TS squared. So the hypotenuse, and then we can say SR squared plus a TR squared. And then we can just say it's a Pythagoras theorem. And then now what you can just do is that since over here we have a TS squared minus a CS squared, what you can just do is to replace a SR with a CS, because SR is equal to a CS, because these two, they are the radius. It means that they are equal lines. So SR over here, SR is equals to a CS because it's a proven above. And then what you can just do now is to say a TS squared is equals to a CS squared plus a TR squared. Do you get me? I hope you do. And now what you can just do over here, since we said a CS squared now, look at this one. Here we have a TS squared minus a CS squared. Look at this one, we have a TS squared, and then we have a CS squared, and we have a TR squared. So what does this mean? That here we have a TS squared minus a CS squared. It means that we did transpose a CS squared, and then we make a TR squared the subject of the formula in this case. So now what you can just do is to transpose a CS squared into to this side, and becomes what we are left with is now a TR squared that is equals to a TS squared and minus a CS squared. And then now what you can just take note of here is that we have a root, and then we have these squares that is a TR squared over here. It means that we did take a square root so that we can get a TR, but not a TR squared. So what you can just do over here is to take a root on the both sides, and then we end up with having a TR that is equals to a root of a TS squared. Now a TS squared, take a look, a TS squared with a CS squared. And then what we can just relate to over here is that a TR is equals to this part. So it means that they did replace a TR over here with a root of a TS squared minus a CS squared, and then a TR is equals to that, and then they did replace that in this type of a question. And then now what you can just look at here is to try to find, to break down whatever that is here. And what I can just remind you of here is just that if you remember the cosine rule, you can quickly relate that here what they did is to try and find one of the sides where pi is equals to a TP squared plus a BP squared. Remember the cosine rule, it states that we have to have in that particular triangle, we have to have two given sides with an included angle. It means that now what you can just look at is to look at the triangle whereby we have a TP squared. Here is the TP squared, and then a BP squared. Here is a BP. You know that a BP is equals to a PC and a QP, because those three, they are the radius. And then what they can give you is that if we have a QP, you can replace it with the BP because they are equal, since they are the radius. And then now we've seen that we have a TP squared with a BP squared. It means that now we can replace that BP with a PC maybe. But let's try to find out if which one of the triangles that they are talking about. So here now it's a minus a 2 TP times a BP and then a cos S, and then times a minus 2 TP times a BP and then a cos S, angle S, and then the cos angle S here, angle S is here, is not in this triangle. So it means that they did use, remember that we have a PQ in this type of in this first question. They requested us to prove that these one are the parallel lines. So we have a PQ here and a SR. Those are the parallel lines. So it means that angle S here should be equals to angle P1 because those are the what are the corresponding angles. So let's just try to say angle S is equals to what angle P1 because those are the corresponding angles, and then the parallel lines are the PQ, that is parallel to SR. And then now, since we have a PQ that we have a P1 that is equals to angle S there, it means that what you can just do is that in place of angle S, we can replace it with the angle P1. So now when we come into this one, in place of this angle S, we can use angle P1, and then you see that the triangle that they used is a triangle what? The triangle that they used is a triangle TQ and then a P. So it means that we have this this side that is a TP, and then we have a side that is a QP, and then the included angle that is an angle P1. So the side that we can get over there is a side TQ. So let's try to find a side TQ in this triangle so that we can end up with something like this one. So now let's look at a triangle TQP, and then what you can just do there is just that a side TQ squared, because we are dealing with a cosine rule over here. So a side that is a TQ squared should be equals to a side that is a TP squared over here, a TQ squared. A TQ squared is a side that we want to find. It has a TP squared, and then a PQ squared with an included angle that is angle P1 over there. So now let's try to find this side that is a TQ, and then we have a TP plus a side that is a QP squared minus 2 times a TP and then times a QP, and then now it's a cos angle P1. So this is a cosine rule that we've used over here. A TQ squared, that is equals to the side that is a TP squared plus a QP squared minus a 2 times a TP times a QP, and then a cos angle P1. So now we know that angle P1 is equals to angle S. We can replace angle P1 since we say that angle S is equals to angle P1 because those are the corresponding angles. And then now we have a side that is a QP that is equals to a side that is a BP. Let's just firstly say so. A side that is a QP is equals to the side that is a BP because those are the radius. They are equal. And then now what you can just do, we can try to replace this side that are equal and with the angles that are equal with. So now a TQ squared, a TQ squared is equals to a TP squared plus, since here we have a QP squared, you can replace that QP with a BP, and then we say a BP, and now we raise it to the power 2, and then we say a minus a 2 a TP, and then times a BP, and then a cos of angle. As since we said over here that angle S is equal to angle P1, we can also say that angle S here. And then now what you can just do, since we can see that over here they tried to find a line that is a TQ. not a TQ squared. So it means that since we have this root here, they introduced a square root on the both sides, whereby they found a side that is a TQ and not a TQ squared. So now what you can just do over here is for us to introduce a square root and say a root over here, a root over here. And then now what you end up having is a TQ, and that is equals to that root over here of a TP squared plus a BP squared minus a 2, a TP times a BP, and then cos angle S over here, and then we close the brackets. And then now we did find a TR and then a TQ. And then now what we have over here is that we have these a side that is a CS and then a BP. So since we did prove that a triangle TQP and then a triangle TRS, they are similar to each other. And what we can just do now, we can try to find corollaries that can help us to find this final answer. So now what we have over here, let's just say now what we have over here is that we have the triangles that are similar to each other, and those triangles are a triangle. We did prove them that they are similar to each other. Those triangles are a triangle TQP. So we have a triangle a TQP, and then that is similar to triangle a TRS, a TRS. They are similar to each other because of angle. We did prove them. We can also say that proven above. And then what you can just do now over here is to try to find the corollaries, and then the corollaries are as follows. We can just take these two letters over here, and then we say a TQ over a TR over a TR over here, and then we can say a QP over a RS, and then we say over here a TP now, a TP over a what? A TS. These are the corollaries, and then we have similar triangles. So proven similar triangles. We say similar triangles over here. So similar triangles over here. That is the reason we take these corollaries. And then now what we can just do over here is to try to find, since we have the side that is a TR and then a side that is a TQ, and that they can give us these, we can replace them with these two. And then what we can just do now is to find a side that is a TR and then a side that is a TQ that can give us this final answer over here. So the side that is a TQ and then a TR, we have them that over there, and then we can take them and say a TQ over a TR, and then is equals to, we've seen that we have also a side that is a CS, and then a side that is a BP. And then what you can just do over here is that we have a side that is a CS, and then a CS is equals to a side that is a SR, and then we have a side that is a BP, and then a BP is equals to the side that is a QP or a PC. And then now a BP, a QP, and then or a what? A PC. So now we have here, we have a QP, and then what I just said is that a BP is equals to a QP, and then we can take this these two. SR is equals to a CS. We can see that we have a RS, and then we have a QP over there. So now it means that the ones that they can give us the final answer over there is a QP over a RS. And then now what you can just do is to try and find since over here we have a what? We have a side that is a TR, a TR that is equals to this, and then over here what you have is a side, then this one you can replace it with a TR. It means that let's try to find a what? let's try to make tr the subject of the formula. So now what we can just do, we can then do like this. Tr is also correct. Tr over tq, tq, and then is equals to rs. Everything that is on the denominator, we make it a numerator now. So we have a sr, and then over a qp. I'm sorry, it's a qp over here. It's a qp, not a qr. So it's a qp. So now what you can just do is to try to make this one the subject of the formula, and then we have a tr that is equals to an sr, and then a times a tq, and then over a qp. And then what you can, what I just said is that this side a qp is also equals to a bp, and then this side sr is also equals to a cs. So now what you can just do, since here, look over here, the final answer, it says a cs and then a bp. So now let's try to replace them, and then we say sr over here. Sr is equals to also is equals to a cs, because those are the radius. Let's say so. And then a QP is equals to a BP, because we have them as a radius. And then now let's just replace them here. Let's replace them, and then we say a TR is equals to a what? SR now. Let's say a CS, and then times a TQ, and then let's say a QP, we can replace it with a BP. And then now let's replace everything and say a TR. Since we said a TR over here is equals to this one, and then a TQ is equals to this one. So it means that we can interchange them and say this one in place of a TQ, and then that one in place of a TR. So now let's do so and say now in place of a TQ, we say, or in place of a tr, we say t root, that is a ts squared minus a cs squared. And then we say over here, in place of a tq, we can say a root over into tp squared plus a bp squared, and minus a 2 tp, and then a times a bp, and then cos angle s. And then now we'll close these brackets, and then we'll say a cs over here. Cs, let's not forget that one. And then over a bp over here. And then now this one is our final answer. I hope it makes sense for you. Now we did find this one. The final answer is this one. So now that's it. That's it for this video, good people. Thanks for watching. Me and you can just meet in the next video. Don't forget to subscribe, to like the video, and to comment down in the comment section, because it does help me a lot to reach more people. And also you can share the video with your friends so that I can reach more views. And one thing I'm requesting from you guys is that help me to reach at least 100 subscribers this year. I can be grateful for that if you can just give me 100 subscribers, and then something will come out.